In this video, we're looking at the simplest resistor circuit possible. It's just a power source and a resistor, and we're going to answer several questions about current, charge, power, and energy. So how about the total current in the circuit? We get this from Ohm's law. So this resistor has a potential difference of 5 volts across it. Maybe you remember Ohm's law as V equals IR. You can quickly turn that around into I equals V over R. And the current flowing through this resistor then would be 5 volts over 220 ohms. When I do this calculation, I get 0.023 amps, just keeping 2 sig figs. So I can visualize it this way. I notice the high terminal of the battery is down here in this example, so the current's flowing counterclockwise. Then I'm asked to get the total charge flowing through the resistor in 10 seconds. So this goes back to the definition of current. That's the rate of charge flow, so delta Q over delta T. And you can always turn this around to find the total amount of charge that's flowed, provided the current is constant, by taking I times delta T. So that's 0.023 amps multiplied by 10 seconds. It's instructive to look at the units here. So there's another way to write an amp. I can see from the definition of I that the units of I are going to be coulombs per second, and then we gave that special name, amps. Well, if an amp is a coulomb per second and then I multiply by seconds, I definitely get coulombs out of this. So I get 0.23 coulombs of charge flowing through that resistor. In part C, we're asked for the power dissipated by the resistor, and you have choices here. The most fundamental definition of power is IV, and that will work on any circuit element. But for resistors in particular, I could use Ohm's law and make a variety of substitutions on this, and as it turns out, I could use V squared over R, or I could use I squared R, or IV. So we could use any one of these three in this example. I think it's probably wisest to use V squared over R because those were the two quantities that were given to us at the beginning, so we don't have to worry about compounding errors as we go through the calculation. So I'm going to use this one. That's 5 volts all squared divided by my 220 ohms. And to 2 sig figs, I get 0.11 watts out of this. Now remember that power is a rate of energy transfer, and it's measured in joules per second. The special name for that is watts. In part D, we're looking at total energy, so it's power over time, giving us a total energy. Definition of power again would be a change in energy over change in time. So if you want that energy, you just solve for it real quick. Delta E is P delta T. Provided P is constant, there's no problem with doing this. And I get 0.11 watts multiplied by 10 seconds. Remember, a watt is a joule per second, so I'm going to get joules out of this. And I find that 1.1 joules of energy has been dissipated through the resistor. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.